Hi everyone, just another fairly quick video here in the linear relationship series. So in this one we're going to be finding the length of a line in between 2 points. So here's an example where they give you a graph, and it's a lot easier often when they give you a graph, but sometimes they won't. So we'll do one example of each. Okay, so in this one, we have to basically figure out the length of the line that goes from here to here. Just imagine there was a straight line drawn between those 2 points. And to do that, we use Pythagoras' theorem. So if you don't know what that is, you might have to look that up. But maybe my explanation here will be enough to learn it or to revise it. So first of all, we have to draw a little triangle on the graph. And I'm going to do that. So it's a right-angled triangle. The longest side is the diagonal one, and that's the length of the line we're trying to find. And we're going to draw 2 more sides of the triangle, which will help us to find that diagonal side. Okay. So here's our 2 sides. Now, you can hopefully see where the right angle of the triangle is. It's over here. Okay, so C is always in Pythagoras' theorem, C is always the long side or the diagonal side. And A and B, it doesn't really matter which ones they are. They're the other 2 sides. And the theorem is C squared equals A squared plus B squared. Okay, so now we've got an equation with 3 variables, C, A, and B. Sorry, 3 pronumerals, C, A, and B. Now, if we can if we know what A is and we know what B is, that means we'll only have 1 variable left, which is C, and we can work it out. So A, it should be pretty clear from this graph that A is actually 2. Okay, A is the distance between here and here, which is the same as this distance over here. So A is 2. So I can substitute 2 right away. And B, you should hopefully see B is this distance here, which is 1, 2, 3, 4, 5, 6. And another way you can find either of these is to do one of these numbers. For example, if we're looking at B, we're looking at the y-axis, and we're looking at the y-coordinate of this point and the y-coordinate of this point. So the y-coordinate of this point is 3, and the y-coordinate of this point is -3. So you can do one of them minus the other. You can do 3 minus -3. And if you did that, you'd realize that these 2 negatives make a positive. And so 3 minus -3, it's the same as 3 plus 3, which is 6. So there's 2 different ways to get this number 6 over here. Okay, so now let's actually square the numbers. So we've got 4 plus 36. Not too worried if you can't work that out straight away. Remember, squared is times it by itself. So 2 squared is 2 times 2. 6 squared is 6 times 6. That's how we got the 36. So now we have C squared equals 40. And the last trick is to realize that you can do a square root to both sides, which is the opposite of squaring something. So if I square root this, that just cancels out the square. So what we're doing is we're square rooting both sides of the equation, and then this cancels out the square. So I've got C equals, and the square root of 40, we can work that out using a calculator. So let's see if this actually lets us do it. It doesn't look like it lets us do a square root. All right, so you'll have to use a scientific calculator. I'm just going to type in to Google and hopefully it'll do it for me. All right, there we go. So 6.32. And if you want to check your answer is reasonable, then you can have a look at the lengths and see if it makes sense. If this is 6, it makes sense that this one is a little bit bigger. 6.32 is an answer that makes sense. So that's good. Now, this one, if they don't give you a graph, you don't have to draw a graph. There's another way of doing it, which is to use this formula. Now, by the way, how they got this formula is basically the algebra version of this. So this is very similar. When they're doing y2 minus y1, I hope you remember that I said one way to find out this length here is to do this y coordinate minus this y coordinate. So if this was 0.2, this y coordinate, the y2 would be 3. And if this was 0.1, y1 would be -3. Because it's the y coordinate of 0.2, the y coordinate of 0.1. So that's how they got this. That's just this whole thing in the brackets is basically just b, the length b. This whole thing in the brackets is basically just the length a. So the formula is like this. Square root of a squared plus b squared. And I hope you remember that at the end we square rooted this side of the equation. So really this formula is exactly the same as what we're doing here. Alright. But you don't need to, understanding the formula is nice, but you definitely need to remember the formula. Alright, so let's use this formula. Now what we have to do is we have to work out, well, what is y2, what's y1, what's x2, and what's x1. Now let's just choose one of these points to be our point 1, and one of them is point 2. Doesn't matter which one you choose. So I wouldn't mind making this a little bit clearer. So I'm gonna see, now we've got some space. We'll call this point 1 and we'll call this point 2. And now you have to remember which one's the x coordinate and which one's the y coordinate. This one is the first one is always the x coordinate. So this has to be x1 because it's 0.1. y1. And this has to be x2 and y2. Now you can put this straight into the formula. So you just rewrite the formula and substitute everything. Hopefully you can see how incredibly useful substitution is. So we write the square root, we write the first bracket. When we get up to x2, we substitute a number for it. We go right all the way over here and find out what x2 is. x2 is 7 minus x1. We have to find out what x1 is. Now, keep in mind x1 is -3. You've got a minus here. But this minus is not the same as that minus, so you can't get them confused. You actually have to write this negative, and then you write x1. So let's do brackets. We have to have another -3. Okay. So there's one negative here, and another negative here, and we have to have both of them. Okay. So we square that because there's a squared here. We write plus because there's a plus here. Keep writing the exact same thing, but when we get up to y2, we have to write 10. Minus y1, we have to write 2. And bracket and squared. And okay, we're almost done. Now we just need to do a bit of maths. If we have two negatives here, that becomes a positive. So let's write equals down the side to keep our working out really neat. That means 7 minus minus 3 is 7 plus 3. So that's 10. That whole thing in the brackets is 10 squared. 10 minus 2 is 8. So we go plus 8 squared. And then we just have to write 100 squared plus 64. Whoop, what am I doing? What am I doing? Sorry. 10 squared is 100, so I don't know why I wrote the squared again. 100 plus 64, so obviously that's 164, square root of 164. Now we'll get Google to tell us what that is again. Or we'll see if we can use the calculator straight away. Yes, we can. So here's the square root symbol. We had 164. That's 12.8. Okay. And there we go. All right. So that is finding the length of a line between 2 points. You can do it with a graph, and you can do it without a graph. And you can even use this formula with a graph if you want to. So there's lots of different ways of doing it. All right, hope you enjoyed that. And let me know if you have any particular questions about that in the comments.